Hello, welcome back to LIVENODING. In this episode, I want to show you a quick breakdown on how I created these procedural effects using geometry nodes and sphere chalk. Okay, so the secret is really using sphere chalk. Oh, wait, 1 second. Okay, so similar to the previous one, previous video, this one is a slight modifications. We have sphere chalk over here doing something in the background. But yeah, previously we saw these effects. So basically we draw curves on top of 3D objects, Suzanne head, and each of the curves will have like this flowing instance that's looping. The Suzanne head should be facing the normal of the surface underneath. It's kind of a little bit better now thanks to Higgsas to show me. It's not yet perfect. I wish all the Suzanne head is facing out, but it's a little bit better. I will show you the improvement of the setup. But underneath is actually sphere chalk, and sphere chalk is generating the curve itself procedurally. So let me reduce the number of curve so we can have less. So we have like, okay, these effects of centipede on top of Suzanne. Let me turn off geometry nodes for now. So we have just a bunch of curve on top of Suzanne. So the curve can be better. It's a slightly chaotic at the moment, but the secret is really populate mesh and the KDTree closest vertices. And the one that's doing the job is really this guy over here. And also the output is this polyline viewer, generating the curve on the fly, and then also merging the curve. Otherwise we end up with hundreds of curve. So the curve is made of multiple strokes, and the strokes is based on the KD3 closest vertices here over here. Okay, so I think, yeah, still recording. It's if you want to know about KD3 closest vertices, this is the nodes and with all the informations, documentation. So it's basically you provide a bunch of curve, and then you give it like give it a vector position where you want to search the nearest position of the points, and then this guy over here, the polyline viewer, will connect the dots and create the lines based on that. So that's simpler. That's basically what it is. It's very simple. So it's gonna generate the curve for you, and the curve is made of multiple strokes, and then we simply pass it into geometry nodes. So we get this result. Slightly more grotesque, kind of like a crowds or whatever running around Suzanne. So the geometry node setup is slightly improved, like I said, thanks to HiggsasXYZ. So geometric curves coming in, we resample the curve using evaluated. You can also use count or length. Anyhow, we capture the attributes here. We didn't use this before. Now what's going on is we are using Suzanne mesh and sample the nearest surface vector normal. Okay, evaluate on domain of points. So the normal coming into and then we capture the attributes of the normal while we keep observing and sampling the curve itself. So we know previously, basically, we get the position of points that's traveling and flowing on the curve, and then we instance Suzanne head on that curve points. So the rest of them is just dealing with the instance, but the one that's we interested in is the normal, how the instance will face. So the directions of the instance is what really matters in this case. So I really want the face of Suzanne facing out. That's the ideal way. In this case, not really 100%, but pretty good. Okay, so the setup, resample, capture the normal of the surface of Suzanne, and then based on the nearest surface there, we just pass the tangent and the normal into align Euler to vector. So this play around with the alignment and then also see the result. While the sampling, of course, there's a vector. It's sampling the normal, the points position, right? So this is the wrap. We have seen this before in the previous video. So this is still the same. So the time kind of keep moving slowly, and then we just wrap the value of time, and then we have multiple times coming in as the vector for sample curve. So a lot of things going on, but it's actually kind of simple once you understand it. So the curve, of course, coming from Sverchok. So if I simplify the whole thing, we can see it over here. It's a donut with Suzanne head traveling on top of it. Yeah, similar effects, similar. So, but it's probably much simpler to understand. So Suzanne head, turn off geometry nodes, turn on the curve itself underneath. So this is the curve made from donuts. I'm using, in this case, I didn't actually separate. I didn't use KDTree closest vertices. I just simply used the original donut torus and then just actually populate it. Populate using points. So that might be interesting for you. We can actually break the curve using Sverchok as well. I use Sverchok to generate the curve because Sverchok has hundreds of nodes dealing with curve making, you know. And then I just simply populate. I can do it this way. Okay, see? Based on the closest vertices and search range, we can create curve that's a little bit more complicated. And we just simply apply geometry nodes underneath. So Suzanne head traveling on top of the curve. So it's a super interesting way to generate curve, because of course you can probably do the same thing using geometry nodes, but just with Sverchok it's much simpler. There's these powerful tools like this, and I think some geometry nodes developer or artists out there also trying to recreate this using geometry nodes. It's probably a lot faster, but in this case, since we just really generate the curve, that's like a once-off thing, and then we merge it using polyline viewer. It's really simple. This is like hundreds of geometry nodes, maybe, yeah, simplified into just a few nodes in Sverchok. So this is the search points. It's finding the points, and then this one is finding the nearest points and creating lines. Okay. We can also use radius, similar, and then turn it into points, and then turn it into something that geometry nodes can understand, which is just curve. And then we just go inside geometry nodes and scatter Suzanne head on top of it. It's not yet simulations. I mean, in reality, you can perhaps continue modify the setup. So instead of static curve at the moment, it's just a static, right? But if you can simulate the curve kind of crawling around Suzanne, that's going to be much more interesting as well. Something you can try in the future. Maybe I can make video in the future, but anyhow, this is as simple as it can. Hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.